Okay, so now we're in the actual procedures that you are supposed to do. And here's the decomp reaction. So we're going to look at that beautiful color, okay? This is copper 2 sulfate pentahydrate, okay? Lovely, all right. So we've got copper 2 sulfate pentahydrate, and we're gonna put some of this in a test tube. Okay, see what those crystals look like? It's really quite beautiful. Very, very super blue, right? The copper is blue in a solution. All right, so we have some of these in our test tube, and it's a decomp reaction. We're gonna try and decompose it with fire. Do you have my strike? Yes, I do. Okay. So we're gonna heat it up, decompose it, and see what happens. And when you're heating up something like this, or really anything, if you're putting a test tube over a Bunsen burner, you wanna hold it at kind of like this 45-degree angle like this. Okay, you don't wanna hold it straight up, because if something bubbled out and you're holding it straight up, whoosh, it bubbles out right onto your hand, okay? But if you hold it like this, if it's gonna bubble, it'll bubble up, but it'll hit that wall of the test tube first, okay? And you can see on the bottom, it's changing color, right? We see we're getting some kind of reaction happening here. What's actually happening is I am dehydrating these crystals, okay? I'm evaporating away, I'm decomposing away all of this water in the pentahydrate part. Okay, you can see that? You see how the crystals are basically losing their color, right? It's a color change for sure. And I know this isn't in your procedures, but it's cool to see either way. We can actually rehydrate this, okay? So we're just gonna add some water, or I am. Here we go. Okay. So I just went and filled up this test tube with a little bit of water, and I am going to add it, get this out of the way so I don't kill myself, okay? I'm gonna add it to our dehydrated crystals here to see what happens, okay? See how the color is coming back? It's pretty awesome, right? I'm rehydrating my crystals. So I can rehydrate and then dehydrate or decompose over and over and over again. I'm gonna get that really lovely blue color back. Pretty darn cool. All right, so this next decomposition reaction is going to be with sodium bicarbonate, okay? So we have some in this lovely jar, okay? And we're gonna put some in our Erlenmeyer flask, and we're gonna test it 2 ways. So we're gonna light 2 splints on fire. The first one I'm going to put in my Erlenmeyer flask and time how long it takes the fire to go out without heating up, without decomposing the sodium bicarbonate. Okay, so we're basically getting like a controlled run, okay? Then the second splint that I light, I'm going to have already heated up my sodium bicarbonate. So I'm decomposing my sodium bicarbonate, and I'm gonna test and see how long this one burns, okay? All right, so you paying attention are going to have to time how long this fire lasts on the sodium bicarbonate, okay? How long the fire on the splint lasts from the sodium bicarbonate either being not heated up, so not decomposed, or once we decompose it, okay? So it says take a good scoop. Here's a good scoop. Good. Okay, and there we go. And now we're going to not light the Bunsen burner underneath it, right? we're just going to light the splint and see how long it takes the splint to go out. Okay, how long it takes the fire to go out. All right, got a good burn going. Ready, set? Okay, so hopefully you timed it. Okay, all right, so now I'm gonna decompose my sodium bicarbonate, okay? Don't reach over your Bunsen burner when you turn on the gas, right? Okay, so let it decompose a little bit. Hopefully some kind of reaction's happening. Right, it's heating up. Isn't this exciting? We watched it burn. Okay. So I can see gases are escaping the top of my Erlenmeyer flask. I don't know if you can see that from your screen, but you can see it from here. So I know that I'm gonna now light my second splint and we're gonna time it, okay? Same thing, I'm gonna get a good light going. About the same as last time. And okay, so we will compare if it took a longer or shorter time for the flame to go out. And then you can compare that with what product was made from the sodium bicarbonate decomposing, okay? Okay, on to my single replacement reactions, okay? Ooh, that one has water. Don't want to use a contaminated test tube. Okay, so this one, part 2A. Put about 20 drops of hydrochloric acid in a test tube and add a small piece of magnesium. Record your observations, okay? So here's my 0.1 molar hydrochloric acid. 20 drops. One, two, three, 4, 5, 6, 7, 8, 9. Oof, who didn't want to watch their professor count to 20 today? 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. It says about 20, okay? There we go. And it says add a small piece of magnesium, maybe. Okay. Let's see if I can do this. Ooh. Okay, I just want to show you what the magnesium looks like. Maybe you can see that. Okay, they're kind of like magnesium shavings. It's pretty cool. All right. We'll cut this out. Okie doke. Just wants a piece. Okay. So, hopefully we can see this. We're going to add some magnesium. Okay, we see bubbles right away. So the hydrochloric acid and the magnesium are definitely reacting. See those bubbles. Exciting. And the next one tells us to add about 20 drops of water into a test tube and then add some calcium turnings. Ooh, okay. And It's actually kind of cool if we can see what it looks like. Flip over, buddy. There you go. Can you see that? All right. I'm gonna add some calcium to it. Okay, so again, we see bubbles. This is just water. Okay, so the calcium turnings and the water are definitely reacting. You see bubbles, you know there's a chemical reaction. Woohoo. Okay, some double replacement reactions. Okay, so we are going to be adding some, let's see, 10 drops of silver nitrate, copper 2 nitrate, and aluminum nitrate into these 3 different test tubes, okay? Pro tip, you can write on your glassware with Sharpie, okay? It's super easy to get that off, so, but this way you won't forget what is actually in your test tubes, okay? You can always get off that Sharpie from your glassware. You can use acetone, NO3, 2. A lot of times it just literally wipes off, but this way, which one's this? See, I already forgot. Aluminum nitrate. Okay, so now all of your test tubes are labeled, and it says add 10 drops to each, okay? So here's my silver nitrate. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, and silver nitrate actually has to be housed in this darker color bottle because it can actually react with light. Fun fact. Here's copper 2 nitrate. So you'll notice with silver nitrate, right? Silver has a 1+ charge. So it's 1 silver ion with 1 nitrate ion. Hang on, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, copper 2 has a 2+ charge, so there's 2 nitrates for the copper. And aluminum has a 3+ charge, so there's 3 nitrates for the aluminum. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so all 3 of these are all 0.1 molar. Okay, 0.1 molar. But this silver nitrate has only 1 nitrate ion per silver. The copper one has double the amount, has 2 nitrates, and the aluminum has triple the amount, has 3 nitrates. So there's 3 times the amount of nitrates in this copper solution than in this silver, so in this aluminum solution than in this silver solution. Neat. All right, then add a few drops of potassium carbonate to each tube and record your observations, okay? I think it'll be difficult to see unless we lift the tube up for you here. So I can work with my left hand, your right. Okay, so here is this added with the silver. You can see immediately a white precipitate formed. Okay, so PPT, I know there's some kind of reaction there. And here's with my copper. Okay, I see that nice blue precipitate. It's copper, so it's going to have something blue in solution if there is a precipitate. So yes, there's a reaction. And last but not least, my aluminum. Okay, you see those kind of white crystals, white precipitate. Okay, so we have a reaction. Now, I will tell you that like on drop 1 with my silver nitrate, there was immediately a precipitate, right? With the copper, I put a couple more drops in, and with the aluminum, I put the most amount of drops in. you can try and figure out why. I know that's not part of your lab, but it's still fun to think about with chem, right? So what is it that makes the aluminum one need more than the silver? Interesting. Okay, so part 3, section B is basically do the exact same thing, but instead of adding potassium carbonate, we're gonna add sodium phosphate. Okay, so I took the liberty of adding all 10 drops of each solution, so you don't have to watch me count to 10 again, okay? And test tube ready here, okay? So now we're gonna be adding sodium phosphate instead. And this is my silver nitrate solution, okay? So you can see a very different color than before, right? We've got this kind of caramel color now, unlike the white precipitate that was the first time, okay? Oof, test tube times with my left hand is difficult. All right, here's my copper 2 nitrate. And I'm adding sodium. Yeah, sodium phosphate, right? You still get that nice blue color. See that? It's in 2 distinct layers. Pretty cool. So homogeneous or heterogeneous? Throw it back to unit 1. All right. And here's our aluminum nitrate. Okay, basically emptied out the whole dropper there. And you can see it definitely has those nice white crystals. I mean, it's pretty solid. You can mix it up. Ooh. And again. Okay, and last one. We are gonna add, what, like 10, oh, let's say, I don't know. Let's make sure we read the directions. 10 drops of nitric acid and phosphoric acid. That's this one. That's why we read the bottles, okay? Into 2 different test tubes. So here we go.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's my nitric acid. Okay. Right here's my phosphoric acid. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Okay. And then add 1 drop of phenolphthalein, okay? 1 drop of PTH. We only have 10 drops of our actual solution in there, right? So we don't want to add a ton of PTH, so just 1 drop. 1. That was on the outside, 1. Okay. Good times. All right, so we'll add 1 drop of our PTH, and then, okay, add a few drops of sodium hydroxide. So I love when it says a few, because how many is that, right? Okay, but we have some 0.5 molar sodium hydroxide, and we only had 0.1 molar nitric and phosphoric acid. So this sodium hydroxide is 5 times the concentration of these 2 solutions, right? 0.1 to 0.5. Oh, well, let's lift it up so you can actually see it. Okay, so just that 1 drop, okay, hitting the solution turned it basic, right? PTH turns pink when the solution is basic. Look at that crazy pink color. That's nice. That is a basic solution. Okay, so that was 3 drops, okay? Turned it that pink. Let's see with this one. Here's 1 drop. Okay, you kind of saw it turn pink, but then it turned back. Okay, which is interesting, really interesting to think about. So 1 drop definitely turned nitric acid pink right away. 1 drop did not turn phosphoric acid pink. 2 drops, pink, and it goes away. 3 drops, pink, goes away. 4 drops, and now we're finally pink, okay? So interesting, and we will definitely get to talking about why it took more drops of the same concentration of sodium hydroxide to turn phosphoric acid pink than nitric acid. And mind you, both of these are 0.1 molar, right? So what is going on? Very interesting. Acid-base chemistry. We're getting there. It's gonna be great. It's so sad and lonely without all of you. Womp, womp, womp. Wish you were here. Hope you're washing your hands. Yay.